Hello, this is Sami. So let's have a review of linear algebra session, what we have learned so far in very summarized and funny way. So what was our first class? The moment that I have my first linear algebra class is this. This is beyond my scope. Got it? So that is the thing. Then after adjusting in the class, I realized that there are lots of difficulty level, and in this the topmost is basically linear algebra. Then after studying mathematics, I start to categorize everything as a matrix. So scalar is one by one matrix. My professor entire semester, he considered everything as a matrix, and me as a student, whenever I have a linear system, I try to do the echelon form. So everything transform in the echelon form. Even at the end, when we were doing the diagonalization, eigenvalues, eigenvector, even in the linear transformation, we are still we were still doing the linear echelon form. And when you learn to know and you are so much perfect in using the echelon form, you feel so much proud. So okay, so solving two variable as a previous method and now in a reduced echelon form. When you have matrices from this is the square matrix and this is the non-square matrix. So you feel very happy when you have square matrix and not. And this is the reverse case. If you have to find the inverse of a matrix. So in case of inverse, when you have to find the inverse, so square matrices had inverse. Although on the different side, when you have non-square matrix, you directly say it has no inverse. Vectors, when we came in the mid in the of the semester, this the vector came, then everything's changed. So you start to say, okay, I don't want to play with you anymore. The previous vector concept, our new vector concept is a multidimensional object. And in physics it was very beautiful, very easy. In linear algebra it is very hard. And then you got to know everything's everywhere is a vector, vectors everywhere. Even you are a vector, I'm a vector. Okay. Eigenvectors and eigen, then came an important topic, eigenvector and eigenvalue. That is very important for the application side. And the concept is very easy. If you have any eigenvector here and you multiply the matrix, its action is basically the scalar multiple of this vector. And there is the same geometric definition here. And when you have eigenvector and you multiply with the matrix or with the scalar multiple, what eigenvector would say, that is the same picture. What really gives you the power if you are LA student? Money, status, or linear eigenvalue? Oh. Diagonalization. If you have to compute a to the power 1000, how would you do this? The main thing is a is diagonalizable. So you can directly compute by computing the d to the power 1000. Next thing, let's suppose you have n by n matrix and it has n eigenvalues. It's mean if this has n distinct eigenvalues, so now you can say A is diagonalizable and A is similar to its diagonal matrix. Oh, that's great. Physicists in every universal problem, they use diagonalizing matrix. Okay. Finding the inverse of a matrix is very tough unless I gave you the information that matrix is diagonally orthogonal. So just do the transpose. Linear transformation. So the first transformation is a rotation matrix, and I start to rotate it as a graphically, not graphically, rotate it as mathematically. Okay, so this is the correct one. Why can't Neo make popcorns? Sorry. because he tries, but everything in kernels goes to zero. You know that the transformation, that kernel is basically the zero of transformation. Then came a summary, the master theorem. Master theorem say if A is invertible, Ax is equal to B is a unique solution. Determinant of A is zero, non-zero, sorry. Column form basis, rank of A is n, no free variable, and zero is not an eigenvalue. That is the same thing in a short. This is a short master theorem, not a complete one. And then in the beginning, you start to know linear algebra is the study of system of linear equation. Then in the mid, you got to know there is a matrices and their properties. And at the end, when the linear transformation started, it is just a study of linear maps and finite dimensional vector spaces. Then came applications. If you are a data scientist, you know you have to eat linear algebra. And then if you are doing a quantum computing thing, then this is basically the linear algebra behind the all quantum computing. And you know, if you know if you want to work in a modern science, then linear algebra is the backbone of machine learning, quantum computing, mathematics, engineering, technology, even AI. What always has been, it was linear algebra. And then barely pass linear algebra. Continue study maths. What came is linear algebra everywhere. Oh my god. Now the post exam thing. The professors say the exam will be easy, everyone is happy, but everyone still get bad score. Oh my god, what the hell is this? So this is just a funny summary of LA course. Hope you enjoyed it. Thank you.